Okay, today we are going to speak about Apicurio Schema Registry on Oracle Cloud infrastructure. Apicurio is a schema registry for Kafka. And first, so I created a DB, a PostgreDB here, because on OCI, we have a new service called my Postgre service, and the database is running. And I did a backup this morning before starting the video. Okay. So I will use this repo for Apicurio because I don't want to use the Apicurio server with the repo in memory on the Docker. I prefer to have a nice repo like this database. Okay, it's more serious in production. Then I created before a cluster Kubernetes here, and I have one node pool on this Kubernetes cluster here with 3 worker nodes. The worker node, on OCI are just VM. So I have 3 VM here, started, ready to execute my pod for the Apicurio schema registry. At the end, I deployed this deployment on my Kubernetes cluster. As you see, it's a quick and dirty demo, so I didn't put that in a secret. Don't do that, please. I just want to go fast. The DB is in a private subnet, so you can see the admin user and the password. And the IP address is not a problem because I will destroy the DB after this video. And mainly in a private subnet, you cannot reach the DB. Here, a deployment, 1 replica, but I did a scale up to 3 replica after the first creation. And 1 service with a load balancer, okay, to reach the pod of Apicurio, okay? Then, if I want to do a check, I can see the 3 pods for Apicurio, okay, here, that are ready. If I want to check the logs of one, for example, this one, just to have a look if all is okay with the DB. Mainly when the Apicurio server starts, it checks if the repository of the schema DB is here, and if not, it create the schema. That all is okay now. As you see, it's running well. Okay. So 3 pods. If I want to check the URL using the load balancer, here, I have my registry. Okay. And a schema that is registered. If I want to check here that all is okay, I can produce a message. Run message. It's okay. As you see, I am using the Apicurio server on OCI from this code that is running on my laptop. And a consumer. Okay. Okay, very fast. I consume the first message that I sent before. Now, I have a VM. I can use 10 thread to query here the Apicurio server. For example, here, the customer avro value here, I can query it, okay, that to check that all is okay. Okay, let's go with 10 thread, the request on the customer avro value, summary report, and I start it's like a mini bench. It's not a bench because I have only one schema. Just to have a feeling about the behavior of this architecture. As you see, it's very fast. I'm not sure because mainly the DB is not working, just ask for one schema. So the schema is in memory, and probably I have cache on Apicurio server, and it's the same. So it's very, very fast. If you want to do a real test, then you have to create a lot of schema and to clear the cache everywhere before starting the bench. Okay. Just I want to check that I have a high availability because the registry is very important. It could not be a single point of failure. It means you need to have more than one schema registry. So I'm going to kill, for example, kubectl, delete. Oh, just to show you, at start, there is no use on the CPU, but now, okay, looking at the 3 pods, okay, I can see that all the pods are working because the CPU increased, okay? Just to check that before killing one. Yes, it's okay. Now I'm going to kill one to delete one pod. For example, the first is one. I delete it. Okay. Just to be sure. And I want to check that I have 0 error here. Oh, nice. 0 error for the moment. Deleted. Okay, top pods. Now I'm going to look at the Apicurio pods. And the deployment will create again the pods because this is the role of the deployment on Kubernetes to check that the pod is running. I kill it, and then the deployment on Kubernetes create again the pods, but I have 0 error here, knowing that I have a load balancing between the 3 pods, and the 3 pods are working with the registry, with the repo on the Postgre database. Okay. Now imagine that I'm doing an error. Oh my God. Okay. Or imagine that I lost all my Kubernetes cluster, or I lost my tenant, and I can have another tenant on OCI. Okay. So I can delete this schema. I'm going to delete this schema. Delete. No schema. Okay. Then I want to reduce the number to check that I can do a restore. Okay. And to check that, first I will scale Apicurio to 0. Okay. I just want to stop just to simulate that nothing is running. Then after that, I will do a restore from my DB. Here, restore. Select the backup source. Okay. This one. Okay, this one, restore. Let's go. I will come back in a few minutes to show you the result. Okay, as you can see, the DB is restored. During the restoration, the status was updated, and now it's active, so it's okay. Then I scale the replica to 3 in order to have our 3 pods. Okay. And now, okay, here, no schema before doing the restore of the database. Refresh. Oh, it's magic. The schema is here. So as you see, you have an architecture. With this architecture, you have several Apicurio server for the schema registry of Kafka. You have a repo that is a Postgre database. So you can scale because you can increase the number of Apicurio server. You can scale here for the DB because you can increase the performance tier here. You know, I am at the minimum, but I can go to 300 IOP, K IOP. Okay, so you can scale. You have high availability because if I kill a pod on Kubernetes, it's not a problem. And you have a disaster recovery architecture because you can restore the database and you can then create Apicurio pods very quickly, okay, using the new database or the whole database that you restore. Okay. At the end, do not forget, it's just a simple test. In a real life and with a real architecture, you need to do a real bench, okay, in order to see if it's okay or not. And this bench should run during a very long time, like for example, 24 hours, in order to check the behavior of the Apicurio server and to check the behavior of the Java technology, because Apicurio server is using a JVM. Okay? Thank you for your attention.